Good afternoon, Francis. Looks like you're the only one here so far. I'll give it another minute or two and see if some other folks join us before we get started. Hey, Michelle.
Hi, Frank.
Welcome, Carol. Okay, so in the interest of time, we're going to go ahead and get started. As a reminder, today's session is being recorded, and we will post this video and the slide deck. It'll go on the CIMC and the CTE director announcements within the CTE hub. Let's see. Yes, all right. Recording's already started. All right, folks, so we are here for the CY92 Exploring Robotics 2026 Rollout webinar. This is the one that is geared for CTE directors and CIMCs. So we're going to start with some course information. This can be found on the 2026 2027 Future CMS system. So with the new school year coming, we have our new cluster groupings, career clusters, and pathways. So this cluster grouping is going to be connecting and supporting success, which is a cross-cutting cluster grouping. And then within that, the cluster is digital technology and computer science. The primary pathway for this course is going to be the robotics pathway. But with this being a middle grades course, of course, it can be applied to any pathway within digital technology and computer science. But if you have a middle school and a high school program, obviously if you're teaching the robotics courses at the high school, it may be in your best interest to also offer the robotics course at your middle grades schools. All right, so course description. I'm not going to read the whole description to you guys, but we've highlighted some call outs. This should be kind of what your students and their parents should understand whenever they're registering for this course. They need to know that robots help people. They solve real-world problems. They're going to use the engineering design process, and they're going to safely design, build, and improve simple robots. They're going to have to do some sort of simple coding, and then their robots are going to move and respond to things. And then obviously they're going to gain knowledge and skills that could potentially lead them to a career. So general information, effective July 1st, within the new school year, the lead consultant will be Mike Renee. This is obviously a pilot course. Since it is middle grades, the POL is going to be local, 45 hours of instruction. We have a recommended max enrollment of 25. If you have a smaller space, I may recommend maybe like 20 students. We'll talk more about that when we start looking at some of the robotic systems. This course does not meet the graduation requirement because it is a middle grades level course, but it will meet the elective offering. So course outcomes. This course has 3 outcomes. Again, these are written in a student, parent, community member language. Basically, these are the 3 most important things that the students should know whenever they complete this course. These are our course standards. All of these are written at the B2 understand level. It is a middle grades course. We're going to start off with safe practices in engineering because safety should be day 1 and go through the rest of the course. They're going to go through what is the role of a robotic system and how does that relate to modern industry today. And then the core of the class is how do we build robots? So what is the structure and the power of a robot? How do you code it to do things such as actions and behaviors? And then how do we enhance our robot in the last standard with sensors? And how do we collect data to improve our designs? Right, so the curriculum guide. Curriculum guide was released today. You can download it right now from the Computer Science, IT, and Technology Education Moodle. It's at the very bottom of the page. Whenever we move to the new Digital Technology and Computer Science CTE Hub on Canvas, we'll obviously have all of those resources migrated into the new system. The new system is supposed to launch sometime in July prior to summer conference. But of course, CIMCs and CT directors, you guys are already using the new system. Okay, so CTSO alignment. Our primary alignment is going to be the Technology Student Association, but you can also find other events that are aligned to this course within the Future Business Leaders of America and Skills USA. CTSOs are intra-curricular. They're not co-curricular. They're not after school. Intra-curricular means that these projects and these competitions can be a direct replacement of course content. If you have a teacher that is needing something and they don't exactly know, maybe an idea for a project or whatnot, it is 100% acceptable for them to go to their CTSOs, pull one of those events, modify it for the classroom, and use that as their course content. So, robotic platform guidance. The next few slides, I've copy and pasted some of the stuff from the guide, so we don't have to pull up the Word document and scroll through it. But we give you some general guidance. Basically, you need to pick a system that can demonstrate safe practices within the robotics classroom or the lab that the teacher is teaching in. They need to be able to apply steps of the engineering design process. So you want a robotic system where they can build things and add on parts to it. It needs to have some sort of structure such as gears, motors, and power. The coding, since this is middle grades, it needs to be a block-based coding system. And we also need to have some sort of sensors and whatnot with that. So we do have some general recommendations. The first one is going to be Lego Education. This is the Spike Prime system. This is the one that most schools have currently. The Spike Prime set is set to retire this June. So they may go on sale. Not saying you should or should not go buy those. Lego has come out with another system, but their new system was just released, and they've also announced that they're ending their partnership with First Robotics. So next school year will be the last year of the first Lego Robotics competition. So if you have Spike, I would hold on to those. This is the new system. They're calling it the Computer Science and AI Hardware. They have a completely new motor, new sensors and whatnot. This system, I would wait to see what their new competition looks like, and kind of look at some general feedback from around the field and other states around the country, because this is brand new. I don't know if there's any issues or kinks that need to be worked out in it yet. Parallax Robots. They offer a system called the ActivityBot 360. This is a cheaper platform. The kids build this. It includes a variety of sensors and whatnot. This is something you would need to pair with another product. Every robot's going to look the same. So if you had, for example, some of the Lego Spike kits sitting around, I would pair that with this Parallax ActivityBot 360. One of the things I really like about Parallax is they are very much about education. They have many, many, many tutorials, lessons, and resources that they give for teachers for free. They're all the time doing webinar online training for free. So even if you don't use their systems, they may have some resources that you could use. Up next, Pittsco Education. We have a Pittsco rep in our state, and their platform is called Tetrix Prime. It's a complete system, all-in-one parts, notebooks, resources, controllers, batteries. This is kind of if you want a one-stop shop, a turnkey solution, Pittsco is a good option. Another option, and this is probably the one that most people are familiar with, is Vex Robotics. If you have any schools that do the robotics competitions, they're probably using the Vex V5 system. If you have any schools doing those competitions, I recommend keeping the old field elements. You can use those in this classroom. Every year, Vex Robotics, the competitive side, they release a new game, and each year has a new field element. Schools pay a few $100s. I think it's like $300 to $400 for those elements. Once that competition season is over, those elements are still good, and you can definitely use them in a course like this. The other systems, such as the Vex IQ system, that one is made out of plastic. It's also a decent system, again, but with it being plastic, when plastic breaks, that's another material you have to replace. And then their third system is the Vex EXP, similar to the V5, but at a cheaper price point. Everything is metal. You have kind of more durability with that, but not the big expense as you would have with the Vex V5 system. And then, of course, if you know of any other systems, you're more than welcome to use that. I've even heard some schools contemplate about just buying a variety of parts, some sort of controller board, and having students 3D print things like that. That would be also acceptable, but kind of depends on the level of teacher and the level of equipment and supplies you have at your school. So in our curriculum guide, there are about 22 essential questions over the entire course. How can leaders support use of essential questions? So we have a sample essential question here. What common mechanism types and simple machines are used in robots, and what do they do? So this should tell the teacher this is something that they need to anchor in their instruction, not just use the question to introduce the units. Ensure teachers revisit the question throughout the lesson cycle, not just at the start. As a leader, you should promote inquiry over answers. Encourage classrooms where students explore, test, and refine ideas, not just memorize the mechanisms. Look for evidence in student work. Students should be able to explain how and why mechanisms function, not just identify the name of them. You can use this as a tool for observation and feedback. During your walkthroughs, ask, how is this lesson helping students answer the essential question? Build teacher clarity and consistency. These questions can support PLCs or planning time, so teachers align how the question is unpacked across all of your classrooms. So leaders ask, is the essential question being used? Teachers should be asking, how am I using it right now in this lesson? We have pages of unpacked content for each standard. So this is the unpacked content for this first essential question. So the overall concept for the lesson should be remember. So that's our RBT level. So the lesson should be at the remember level. Common mechanism types and simple machines. And then it goes into simple machines used in robots. What are the different types? I see levers, wheels, and axles. And we talk about common mechanism types in robots. And then it goes deeper down if the teacher doesn't know what that information is. This is for them to use to build their lessons, activities, and projects. So supporting unpacked content. Ensure the depth beyond vocabulary. Look for instruction that moves past naming parts towards explaining the function and their purpose. Prioritize conceptual understanding. Students should understand how force, motion, and power transfer, not just list them. We should support coherent progression. Teachers should build from simple machines to more complex robotic systems logically. Look for the application and contents. Students should apply concepts and builds, not just learn them in isolation. Use this as a walkthrough lens. Ask, are the students explaining how and why these mechanisms work in this robot? Ensure access to the materials and the experience. Kits, robots, simulations, it's got to be available for some sort of hands-on exploration. And promote consistency across your classrooms. Teachers should align on which mechanisms are emphasized and how deeply. If you have multiple teachers across your system teaching this, they should be PLTing together. Leaders ensure the conditions for quality. Teachers are creating the experience of learning. All right, so here's an example of a teacher brief. We have a page to a page and a half of teacher briefs for all of these, for each standard. So it kind of tells the teacher kind of a mindset to go through this unit. So we say things like instruction should remain conceptual and observable. Students are not expected to use formulas for torque and gear, but they should be able to explain the trade-offs, such as why does torque do this? Why does torque do this when I decrease this value? And then we also point out some best practices. So what should the teacher emphasize? What are some things that they should have the students collect and write down and put in their notebooks? So supporting teacher briefs, prioritize conceptual understanding over the computation. So students should be able to explain, not just calculate formulas. Look for systems thinking. Instruction should connect the structure, power, and mechanisms. We don't want to teach them in isolation. Evidence-based reasoning. Students should justify decisions using data from their testing. Promote inquiry-driven classrooms. Learning should center on investigation and experimentation, not lecture-heavy delivery. Support a clear learning progression. So the student should observe things. They should do a controlled test. They should apply that to their design challenge. They should do iterations. Look for purposeful data collection. Students should be gathering and using measurable data: time, distance, success rate, load, what is the capacity of the robot, things like that. Ensure access to an iterative experience. Students need the time and the materials to test, revise, go back, and improve their designs, and then do that all over again. Use your walkthrough as a probe to thinking. Ask your teachers, what evidence do students have for why their design works? So leaders look for the evidence of inquiry, systems thinking, and data use. Teachers do the design investigations that guide the testing and that require explanation from their students. We also give about a page to 2 pages of instructional resources for all of our standards. These are for teachers to explore and build their lesson plans so they're not starting from scratch. So I have some examples here. I may not be using First Lego League in my classroom, but I see that this is an engineering notebook and documentation resources. This might be a great resource for me to go to, and I can use that and adapt it for my own use in my classroom. The standards site has a lot of safety documentation, posters, videos, safety quiz, forums if there's any sort of issues in the classroom. Your school may already have a system in place to collect that, but if they don't, this is another great resource. Another example could be a sample lesson from partners. You can use those just as is. Some days, you just don't have the capacity to have a lesson ready. We've provided some from our partners. You can take those lessons and enhance them. Other supports may include posters, handouts, and videos. Leaders ensure the right tools are available and aligned. So point your teachers to these instructional resources. The teachers should turn those tools into meaningful learning experiences. Okay, so now we're going to talk about the pilot here and the supports. So we have sent the standards crosswalks to First Robotics, Lego Education, Parallax, Pitsco, Robotics, and Vex Robotics. Once they complete those, I've already got a confirmation, I know from First and Pitsco and Lego. Once they complete those, we will post them to the new PLC, either the Moodle or the Hub, depending on what time it is, whenever they send those back. So that'll be pre-built lessons aligned to this standard teaches, this lesson or this activity, this competition, this project, whatever the vendor offers, we'll have those available for you guys. We're also going to have a pathway teacher lead for robotics in general. This will support the middle grades and then the 2 high school courses. We're going to launch those applications sometime in April. The teachers will need the support of their building principal and their CTE director. So if you already know a teacher that is really good at robotics, maybe they do competitive robotics, and you recommend them, send us their name in an email, or whenever you see the application come out, send it to them. The new pathway teacher lead, we're planning to have those announced at summer conference. And then they're more than likely going to do the same system we did this year. They will host monthly statewide PLC meetings for robotics. They will provide some professional development. And then they will also be there to answer questions from teachers and other staff in the CTE world. So as with all of our other pilots, we're going to have our check-in meetings and our surveys. Again, I put this tentative just because it's too early for us to know for sure the exact dates of these pilot meetings and whatnot. Those will come out closer to the new school year. Whenever the meetings come out and the surveys, please encourage your teachers to go to the meetings. If they can't go to the meetings, at least fill out the surveys. If they want changes, changes can only be made if we have data to support that. That's why we send out the surveys. If I don't get any feedback, I guess if Mike doesn't get any feedback, then he's going to assume that this course is good to go as is, and then we don't make any changes. Currently, we're doing CSET office hours. It's every Tuesday afternoon at 4 o'clock. There's our link to it. I assume we're also going to continue to do CSET office hours in the new school year, but the day and the time may change. So that's why this one is tentative. All right, and we're now going to go into our question and answers. So I'll open the floor for questions and answers. Okay, I, I don't see any questions. If anyone has a question, you can unmute. I will stop the recording.